Hello, my name is Meredith Renaud, and this is my Physics 2212 section X07 Lab 3 Magnetic Dipole Lab Report. In this lab, we focused on a magnet, and the purpose was to determine a magnet's magnetic dipole moment due to the distance dependent of the magnetic field, and to measure the magnetic field due to a permanent dipole magnet. Some physics principles used were the Biot-Savart law, which was listed below, and ln of bx equals ln k plus n ln of r. As a result, the distance between the magnet and the magnetometer decreases, and the magnetic field increases. On the left, you'll see options of what happens as the magnetometer moves closer to the magnet. I selected that as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases, and this is proven with my data on the right. On the right is also included the graph and the plot of my points. As you can see, my equation is y equals negative 4.9267x minus 18.469. This means that the n value is negative 4.9267. And while this value is supposed to be closer to negative 3, I believe this error was because of a fracture in my magnet. So in order to find the mu value, I simply did e to the negative 18.469 divided by 2 times mu naught divided by 4 pi, and that gave me the values that I used to calculate the rest of the calculations within my coding on the next slide. In order to complete the coding portion of this lab, I had to create a function similar to what was done in Lab 0, but this time the function was called dipole B and focused on the magnetic dipole field. This helped create the arrows you see on the right. The code on the left goes explicitly into this process. I'll explicitly talk about r-axis 1. So r-axis 1, I did the observation axis minus the magnetic position, because that would be your final minus your initial position. Then to find the b-axis, I called my dipole B function in order to find the field value. The arrow position would be the observation location at the end. I wanted the color to be orange since that would be on axis, and the axis would be the B scale since it was too small to see originally, times the B axis 1. And then I printed that in order for you to see the values. I repeated this process for each arrow as you can see on the left-hand side, including the purple arrow that was 45 degrees from the magnet. The orange arrows represent those that were on axis, while the blue arrows were off axis or perpendicular to the magnet, and once again the purple represented a 45-degree observation location. Some final questions in order to wrap up the lab are: what if you had not oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? Because we compensated for magnetic north, we were able to say that one of the values for the x component was 0, which made our calculations much easier. If we had not done this, then another x component would have been introduced, and that would have made the complications much more complex. But this variation would only appear in the x component. And what if you were to stick 2 identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? If 2 magnets were stuck end to end, that would make double the length of a magnet and twice the magnetic field. If the magnetic field were 2 times as strong, then the distances would be smaller in order to find the Rx values. Thank you for watching my lab report 3.